Okay, now, on to our next special type of triangle, the equilateral triangle. These are probably the easiest types of triangles to deal with. Equilateral triangle is equilateral only if it is equiangular. So what this is saying is that if angle A is equal to angle B is equal to angle C, equiangular, then we have equilateral. The sides are equal. So AB equals BC, why did I put plus, equals AC. And the reversal is also true. If AB is equal to BC is equal to AC, then the measure of angle A is equal to the measure of angle B, which is equal to the measure of angle C. So, if all the angles are the same, all the sides are the same. If all the sides are the same, all the angles are the same. That's what we want to be looking for. Now, one thing to note is that if all the angles are the same, then each angle has to be 60 degrees. Because all the interior angles add up to 180, and if they all contain the same measure, the only combination of numbers that would work is 60, 60, and 60. So looking at problem 11, we can easily determine that angle C must be 60. 60 plus 60 plus 60 is 180. This is what part of what makes equilateral triangles so easy to work with, is because you always know what the angle is equal to. Now we want to find out what BC and AC are. Well, it's equilateral. All the sides are the same. If AB is 9 feet, BC must be 9 feet. And AC must be 9 feet as well. All the sides are the same. So 9 feet and 9 feet. Very simple. Now, problem 12 is just asking us what are all the angles equal to. Again, even if we didn't know that it was 60, we know that it's equiangular. All the angles have the same measure. So if I said that they were all equal to x, some unknown, then all the interior angles add up to 180, and therefore the sum of those angles, x plus x plus x, is 3x, and dividing by 3 on both sides give us that x is equal to 60. So angle J is 60 degrees, angle K is 60 degrees, and angle L is 60 degrees as well. So, problem 13, a little bit more tricky. It's got some algebra in there, but I think we'll be alright. So, it wants us to find x and y. Well, I noticed that 7x minus 3 is the measure of the angle. And each angle is equal to 60. So, I can set that expression 7x minus 3 is equal to 60. You could have said, oh, all the angles must be 7x minus 3. Because all the angles are the same. And then say 7x minus 3 plus 7x minus 3 plus 7x minus 3 is equal to 180. That would have been a lot more work. It's much easier to do it this way. So, add 3 on both sides to get 7x equals 63. And then, by dividing by 7, we see that x is equal to 9. Now, that was pretty easy. Now let's solve for y. We're given the measures of 3 of the sides. 14y minus 59, 9y plus 1, 11y minus 23. All the sides are the same, so just pick the easiest one to work with. 9y plus 1 looks fairly easy to work with. So I have 9y plus 1. set it equal to any of the other two sides. So how about 11y minus 23? Seems reasonable. So let's add 23 on both sides. We have 9y plus 24 is equal to 11y. Subtract 9y on both sides, and we will get that 24 is equal to 3y. Then, with division by 3, we have that y is equal to 8. And there it is. That is how simple it can be to work with equilateral triangles. There is not a whole lot to it.